Okay. All right, I'm going to go ahead and get started, everybody. Let me just take this off here. All right. My name is Ramece, and welcome to Dinosaur Training 101, Getting to Know Your New Pet. Wait, no, is this the wrong talk? Just kidding. I think I'm funny, or, as my wife would say, funny looking. So let's get started. I'm here to talk to you today about eating the elephant, leveraging data analytics to tackle everyday security problems and deliver actionable intelligence, as if our job already wasn't hard enough as it is. By day, I work as a research analyst for NTT Security. I primarily work on analyzing packet captures, malware, covert channels, communications, the fun stuff that my wife likes to have me explain when she needs to fall asleep. By night, according to my daughter, I'm known as the daddy princess, and there may or may not be pictures of me dressed up as a princess online, but according to her, I will forever be Anna and never Elsa. But hopefully one day, I hope I get to play the role of Elsa and be a true princess. All right, so what we're going to cover today, eating the elephant. I know that's a long title. We're going to also cover what is actionable intelligence. Really, it's just a matter of perspective, in my opinion. We're going to go over a case study that I've been working on called the C4 URL list. Some of you may have seen this, and then we're actually going to go ahead and eat that elephant. Don't worry, I have hot sauce, other condiments. You're free to add as you see fit. Some people like to go au naturel and eat it straight up, but hey, whatever works for you. Data enrichment and organization. That's something that I feel is very important when you're eating an elephant. Have a plan for how you're gonna eat that meal. It's like going to one of those big family style restaurants and they've got a 7-course meal, and you kind of have to pace yourself, because if you fill up on the appetizers, you have no room for dessert at the end. It's like one of those situations. 21 questions, the data interview. Because really, when you're getting to know your data, it is an interview process. You got to learn to ask the right questions, really know how to get involved with it. Actionable findings, recommendations, and we'll have a Q&A following that. So what is eating the elephant? For me, eating the elephant is a systematic process of breaking a large problem into smaller, more manageable problems. My coworkers have heard me say before, how do you eat an elephant? And I'll say one bite at a time. And I purposely use byte there because I'm a packet guy, as you'll soon learn. I'm really a packet junkie. I'm going through a 12-step program to kind of get that fixed. It's not working at all, but I'm okay with that. All right, what is actionable intelligence? Threat intel is a hot topic right now. We could ask everyone in this room what is actionable intelligence, and they might have different responses. Everybody's going to be right. People are going to agree. People are going to disagree. It's like, okay, who's on Team Jacob? Who's on Team Edward? The room will divide. And then they're like, forget Twilight. I don't like Twilight. I want to go old school. And that's fine. But for me, actionable intelligence are things that I can act upon. Something that we can react to, gain a greater insight, adapt change, adopt policy. Because this is what this is about. Because when our bosses come to us, they want to know, how are we going to save the world in the next 5 minutes before commercial break? We all deal with this every day. So that's what intelligence is, really relative to the situation you're working on. The background story. So in 2016, somebody posted a list that they called the C4 URL list. Why they called it C4, I'm not sure. Maybe it's a cool sounding name. It had some significance to them. In this list, it contained URLs for 24,000 IoT devices, specifically CCTV cameras that were out there that he or she had found. So for me, being a data junkie as well as a packet junkie, because I have to have multiple devices, I started looking into that. And this is a type of scenario that we all might encounter. Your boss, somebody in your organization says, hey, we just saw this list on Twitter, or it came from this feed, this intelligence feed of IP addresses or URLs. We want you to use that to protect our organization. And we needed it yesterday. And it's like, so how do you go about handling this? This list, 24,000, it could be triple that. It could be in the millions. And your bosses, or anyone that doesn't deal with data in that magnitude, what the problem is. Why can't we handle this? How do you tackle this problem? So I have some options for that. You might be thinking, what am I supposed to do with this? Are you serious? Was this on purpose? And then you find out it was on purpose. And it's like, wow, they really want me to handle this. So what do we do from there? Well, we can eat the elephant. We can add data enrichment to it. Sorry, I think okay, yeah. We add data enrichment to it, to the URL. So we develop a free association of the data, of the plot lines, brainstorming of what we want to look into. We tie the data into other data sets to add value and context and let the data talk to you, because small steps equal big gains. So basically what this is to the person that put this list out there, it's just URLs. To them, it's like, all right, this applies to this IoT camera family, whatever information they have. Maybe they didn't release it. They don't want to release it, the context behind it. But how do we backfill all that information? Because our bosses, whether it be for organization or for our own self-gratification, how do we add enrichment and context to this? And you honestly, you want to let the data talk to you. As you start building these data sets, let the data talk to you. You're going to see patterns that are going to emerge. Everyone in here will see different patterns based on your own experience. Depending on your background, like I was talking with someone earlier, they're a ransomware specialist. So if they might see an IP address or a provider that to me is nothing. It's completely innocuous. I don't see a whole lot of coming out of there, but to he or she, they're like, wait a minute, that's part of a command and control, and I've been tracking them for months. So now you can siphon that data off to them and let them work their magic on that. All right, and so here's the URL list. And I'm going to walk around here. So here's the URL list. So as we're looking, and any cats in the audience, they're going to run for the screen. As you're looking through here, there are different aspects to it that are of interest. So you'll see that there's counter, video, JPEG, a few other things, and it's like, well, what does that mean? Does that have any significance? What kind of value can I grab from that other than really confusing my firewall or IDS system? And we're going to go into that. Where do we go from here? What enrichment can we add? So we're going to go over some options. Here are some possible solutions. You could block all of these IP addresses with the associated URLs. It's doable. 24,000 is probably going to have more of a negative impact on your equipment than good. And then also, really, what are you accomplishing by blocking 24,000 IP addresses at that particular time? You might need to scale it back. So we move on to option 2. We block all the domains associated with the URLs. Let's go ahead and do NS lookups and see, all right, well, let's block it from here and see what we can catch from there. Also doable, but you're going to have the same or similar impact as you would from option 1. So option 3, we start to get creative. I'm going to close my eyes until the data goes away. It's kind of like when I'm trying to get my daughter to eat her vegetables, and she closes her eyes and she says, no, Daddy, I'm not going to eat the broccoli. But then when she opens them, the broccoli's still there. Same thing here, except like just how you guys gave me those funny looks for doing that, your boss is going to look at you and say, what are you talking about? They just did this on CSI whatever. The code shows up red, so when I open up malware on the screen, it turns red, and it has a skull and crossbones, and so I know it's bad, and They just cracked that 1024-bit encryption in 30 seconds before the last commercial break. Why can't you do that? And true story, I actually had somebody say that to me once. I found some encrypted malware, and they were like, why can't you break it? They're like, my brother-in-law's sister's father's best friend's cousin's neighbor who works for the NSA says that that's possible and it can be done in like 2 seconds. And they said it's easy. He said IT security is easy. Well, if it were easy, everybody would be doing it. So that really only leaves us with option 4. We eat the elephant. And what we do with that is we own the problem. Own it. Ownage. And this is how I like to approach things. I own these problems. A good friend of mine and coworker gave me a list of 65,000 IP addresses once and said, hey, go find something's wrong with this. Tell me what's in there. And I'm like, well, I've never really worked with a query that big, but let's see what'll happen. Because I'm the kind of guy, I'll go push the red button. I don't know what it does, but it's shiny, and I'm going to push it. So I loaded it in, and I actually came back with some matches, about 100. But there were 9 in there that were really interesting because it was tied to a botnet that I was tracking. And I had just seen the updates go out this morning, and I said, well, if this is it, here are the URLs, here is agents that they're using, here are the binaries that are associated, and then if they are a part of it, they were just updated at 6 a.m. So look for 6 a.m. timestamps. And lo and behold, that's what he found. And that was following this process was, stepping through the problem. And there are probably people in here, they already do this. They have lots of other methods to tie in. And this is not telling you to hey, follow this method tooth and nail. Like Ramece says, this is step 1, this is step 2. No, it's really a guidance, a suggestion, augmented into what you already do to make your data that much better. So when your boss comes in and they hand you this list of 10,000 addresses or whatever, you've got this. And you're like, okay, yeah, and then you can make it look like TV. All right, so we're going to go, what's good about this data? Because I don't like to say that data is bad. There's good data and then there's good-ish data. The good-ish data I might not have a use for right now. So it's kind of like, I don't really need this information, but I'm going to hold on to it because you never know, a contextual situation may come up where I need to apply it. So store off the data, have some way to search it and augment it, and I do this all with data sets. Pandas is probably the standard and the favorite, and the Pandas people are going to hate me for saying this, but I use S-frame a lot, and that's just coming from the courses through Coursera. They use S-frames in the machine learning courses, but the Pandas people are also going to not like this even more because I will flip-flop between Pandas and S-frame depending on what I need to do. Now, I'm sure I just created a wormhole somewhere at some other part of the world, but that's what works for me. So the good part to this, we see that we have multiple commonalities, as I had pointed out, with the URIs. We have source ports that were in there. Source port information is good for looking for things on your network because it's not just ingress, it's egress that we're also looking at. IP addresses. Come on, who in here does not want IP addresses? I mean, IP addresses are gold. When people want to know what they need to block, what they need to do, oh, what are those IP addresses? Well, we got a whole bunch in here. But what other context can we add to it? What other things can we extend into that? The good-ish information. These are CCTV cameras, allegedly. IP cameras, allegedly. I don't know. I'm taking the person's word for it, but we kind of need to trust but verify. And then also, we have volume. There's over 24,000 entries in here. So that kind of gives us a good perspective as to what is going on. So, as we're going through here, I'm going to walk over, say I wish I had Vanna White as an assistant right now. So this is a mind map for it. As I pointed out, I like to do free association. What you guys don't know is my background is in psychology, primarily focusing on forensic psychology with a minor in criminal justice. So what that means is When you bang on your computers because your code didn't work, because obviously it's not your fault, your computer comes and talks to me, and then depending on how bad you were to the computer, it'll tell me your dirty secrets. So I have a thriving practice doing that. With this mind map, we start with data enrichment. So we map out the associated binaries, other associated IP addresses, industry verticals, Virustotal, because we want to know what viruses are being introduced here, geolocation. And we can also tie in other sources. So the malware archive and IP address archive that I have, I can funnel that into there. Detox, which is a primary source of information for me, funnel that in. They really hooked me up with access for this. NRL HoneyNet, that's my personal HoneyNet that's out there. And then the IP camera list. And then here are just some of the relationships that we can look to establish. And this list isn't complete. Depending upon how you, the individual, are going through this list will change. There are things on here, I'm sure, that some people will look to and say, wow, I can add this column here, and we can take that data down a whole nother path. And the list is not meant to be complete. It's meant to get you started. Get that brain juice going, and so you can figure out, hey, how do I want to apply this? If you have different analysts, like for this, if you look at it, you can see that a lot of it is focused in on, like I like to look at the geopolitical spectrum of how they apply to attacks. So if you have someone else that is focusing on ransomware, or some other attack vector, you can funnel that to them and say, hey, what are you seeing from here? Is any of this data correlate to what you're seeing? Hey, here's a mind map of what we are kind of brainstorming to get things done. And then also another positive is managers love pretty maps. So if you want, you can always put something like this in there. And it does have usefulness. It does show, where your minds are thinking and where you can actually apply other context. So we start by adding perspective to this. We start by adding the industry vertical information. Now, and the geolocation. We all know that geolocation is pivotal to our analysis structure. So by adding this in there, we know we can identify the top originating countries, top originating providers, categories for any vertical trends in countries. So why is this important, for targeting and also your targeting industry? If you're a global company and you're seeing that several of these IP addresses are mapping to specific verticals like retail, and you're like, wait a minute, we have a huge retail presence and we happen to also sell these cameras. Do any of our customers show up on this list? And in what capacity? What malware or binary are they associated with? Also, industrial espionage is a real thing. These cameras are not only just for launching DDoS attacks. They also are entry points into networks, so that way they can exfiltrate data. Because I've had those conversations when a mail server or something's been compromised, and they are trying to exfiltrate data, and it's like, yeah, your mail server is trying to hack me, and they're like, it's a mail server. It's not hacking you. It delivers mail. It receives mail. And so you spend an hour or so trying to convince somebody why they need to take action. And that's, just curious, show of hands, how many people have had a conversation like that? Yeah, so obviously it doesn't happen. These people, they're just supporters and they're putting up their hands. No, thank you everybody for putting up your hands. But this does happen. So, Virustotal and Detox. Virustotal, obvious. I'm sure everybody here has heard of Virustotal, adding in collaborated identified malware information. Because when it comes down to where you're delivering your actionable intel to whomever, they want one of the key questions, viruses. Does this map out to anything? What can we look for? Hey, why wasn't this vendor detecting it? Well, you can have all that in there. And then also your virus detectability can tell you a lot about what's happening. Like there's a sample I was looking at a few days ago that's tied into IoT, and it's, as of a couple of days ago, it's only detected by 2 vendors, and they're not in the top, when I would consider, the top heavy hitter vendor list. It's not Symantec or McAfee or, Norton, any of those. It's 2 what I would consider, the off-brand, the less commonly known, and that's very telling. It's like, well, okay, wait a minute. All these other guys say that this is harmless, but you have these 2 that say it's not. And when I'm looking at the structures of the malware, of the binary itself, there's definitely some peculiarities in there, in the structure, which makes me think that's why it's not being detected. So also something to look into that you can tie in. My bread and butter, PCAP analysis. I am a PCAP junkie, especially when it comes to protocol anomalies. You want to really, like this laser pointer and a cat, like throw an anomaly at me, and I'm like that cat chasing the laser pointer. I will zip after it all around the room, and I can get tunnel vision and get focused on it. But that can also be a pitfall, protocol anomalies. I categorize anomalies as things that are out of place but have not yet been confirmed to be good or bad. And what that does is that helps keep me balanced. So I know, so just because I see a malformed ICMP packet, like the kind you would see in Nmap, and for folks that know what I'm talking about, looking at PCAP that I showed you yesterday, you'll see what I'm talking about. So that ICMP in there, accordance with the RFC, it's and the original design specifications, it does not follow it. But just because it doesn't follow it doesn't mean it's bad. That's just something that Nmap has done. So those kinds of things, when you start tracking and identifying those traits, those are things to keep into consideration. Other enrichment opportunities, the server headers and the index pages. And we'll go deeper into this later. IP cameras, like most IoT devices, are just web servers that are bundled in a pretty pink box that we paid a lot of money for. That's really what it comes down to in its simplest form. So web servers are very chatty by default. Hey, I'm running Apache 4.2, or I'm running Apache 1.3 and PHP 4.2. For the people that are out there, the pen testers and the web coders, that just screams, hello, hack me. It was like, hey, I am open for business. Come on in and root me. I mean, that's what that's saying. These cameras, a lot of times they do the same thing. There's a lot of poor CGI implementations. AV Tech there was a Trend Micro just released a report on AV Tech firmware where they had a wide open CGI vulnerability. Forget going in through BusyBox. We just use CGI and let that do my job for me. You can identify configuration URLs and then potentially vendors, because that's what it comes down to. What are the vendors that are on our network? And this is how you can apply this context to what you're working on. Where are your cameras? Are they vulnerable? Do you have cameras on your network? Now, most people will say no. We don't have cameras on their network because they know we don't have a CCTV system set up. We don't have IP cameras. But I guarantee there's probably at least one user that has set up some kind of rogue camera on their network because they want to watch their goldfish at home while they're away on the weekends. That's a security vulnerability. That's a way in. So now you can start identifying these trends, and you can hopefully nip them before they get out of control. So data organization. How do I organize the data? As I said earlier, I use Pandas and S-frames, and I also will use Mongo database to store a lot of the data ahead of time before I load it into data frames. As of yet, the largest data frame that I've worked with was just over 176 million events, pointing out to about just under 1 billion data points. And I worked all that with data frames. Doing that with Mongo, unless you have a really robust setup, not going to happen. At least not in a feasible amount of time. Data frames help eliminate that. And then they also make the data portable. So instead of sending a 17 gig CSV file, which that would roughly average out to, you can send them a 5 megabyte data frame and say, hey, here's all the data. And then you can segment all of the information. Because this is what I did. With each one, I'll segment the different portions of the analysis into different frames. And then I'll build a matrix of all the things that overlapped. So in this, I had roughly 12,000 IP addresses that I was able to gather information on. In the overlaps, where I was able to tie in directly attributable information, it came back to about 2,000. So that definitely on its own helped me narrow down the playing field for what I needed to look into. And those familiar with intelligence analysis, building a matrix is something that happens. It's one of the analytical techniques that you can do. For me, I like to split everything apart at first and then combine into a matrix because, well, I get hit in the head a lot. I'm married. I'll mess up. So this allows me to go back, start over, and reimagine the data. And so keeping everything separated and isolated at first really does help in that context. And I've done this with PCAPs. For me, I like to split PCAPs into their different protocols, and then any one-offs, and then I'll merge them all in. I'll have a common identifier, will usually be an IP address, so that way I can index everything and merge it. It just makes it all easier for me. This is a sample of what we were looking at. So this is the Jupyter notebook that I was doing all this in. And once I'm done with all of this, I will make all this available. So all the code, all the data, you'll be able to play with and analyze on your own. So what this is one particular company that came up, Trendwind SA. So we can see when these are all the particulars. So this is targeting the ARM platform. This particular associated binary was hitting just over 190,000 IP addresses. There's the content length from the headers. There are other things we can trend on. Hey, the server says it's a NetWave IP camera. There just happen to be NetWave IP cameras out there. We see it's from Uruguay. And Kaspersky, McAfee, and Trend Micro have all identified this as Mirai. And if you haven't heard about Mirai, I mean, that's definitely the IoT bot that's been wreaking the most havoc out there. I suggest reading anything by Malware Must Die on the subject. Amazing stuff. Though the men and women that are there, they do some top-notch work, and it's very well documented, and I highly recommend that you read it. But that's just a snapshot of some of the information that you can gather from here and keep things moving forward. So the data interview, because as I said earlier, this is an interview. When you're asking your data questions, it's just like when we're being interviewed for jobs, when we get cold calls from the recruiters, they're like, hi, I know you were all security professionals, but we have an excellent sysadmin job for you. And it's 500 miles away for you. You want to commute? I mean, how many of us have gotten that call? It's like, did you even read my resume? I haven't been a sysadmin for 20 years. I mean, thanks, I appreciate the call, but no thank you. So same thing when you're asking your data these questions. You ask the right questions, you find gold. It's just like streamlining your applicants. If you know the good questions to ask them from looking at the data, their resume, you're like, wow, there is an untapped jewel just sitting right there. We need to hire that person, because I don't even think they know the full potential of what they can do yet. But you ask the wrong questions, like, oh, we're looking for somebody that, knows, checkpoint firewalls. And they're like, well, I don't know checkpoint, but I know these other firewalls. And it's like, well, but we're specifically looking for checkpoint. We don't have checkpoint, but that's what we're looking for. Again, those are the kinds of questions you see, and you're really not getting anywhere with that. So some of the questions that I usually like to ask my data are, What are the identifiers? Are there any vulnerabilities? What vendors are affected? And all of these can be answered depending on the context of the data and what you have available. So your actionable findings. So there are some of the things that I found just from looking at all of the data. Like, what does all this boil down to? Okay, Ramece, you're sitting here telling us you've got over 24,000 IP addresses. You've said you found some binaries. You've said you found this and that. So what does that mean? Because again, we still have to solve this problem. Because you all are my customers. You want to know what is some actionable intelligence that you can take out of this. Like, why are we sitting here? Well, just for some observations coming around here, I mapped everything to government, retail, municipal, education, internet service, and telecommunications. Some of these are going to be no-brainers to you. But municipality, I added that because that's dealing with a particular city. Because again, if you work for a city government, and are we showing up on there? Wow, municipality showed up. Let's see what's happening there. Do we show up on that list? Wait, we use that camera system that municipality is working. Maybe we should have a look. That actually happened before Inauguration Day. Supposedly, the CCTV cameras around Washington, D.C. were compromised by ransomware. Are you running those cameras? Are you also being affected? What are some things that have been happening on your network surrounding that? And we also saw 28 different camera versions. Based on that, NetWave was the most common, coming across 27 countries. United States and Vietnam were at the top two. United States, no-brainer there. We're seeing things across telecommunications and internet services. So that's not uncommon. But what the differentiator is, what I would list as telecommunications, those are people that provide internet service and some other type of service, like mobile phone. So we have a internet service compatibility, and we also have mobile phones. So now that leads me to think, are these coming from their mobile network? Because we know that there can be security implications there. The top ports, 86 and 60,001. So when you're looking for these devices on your network, you can start targeting those ports. Do we have any services listing on here for those services, for those ports? Should we have those on here? Now you can start identifying that and trending that out. And the binary targeting was across 220,000 IP addresses, 180 countries, 10,000 organizations. Basically, they were hitting everything. Some of them were targeted, but mostly it was, we're just going to plug in some random IP ranges, and we're going to hope for the best. So what does that mean? I like to add data visuals to this. So what this cluster is telling us, besides making our eyes bleed, is that everything is tied into telecommunications, because I know you all can read that, right? Yeah, so this is tied into telecommunications, internet services, and which we saw this. We saw that everything was clustered into these two areas, which is fine. But for me, how I like to look at this data, I'm not worried about so much about these guys here. It's like, yeah, I know that. They're supposed to be there. I'm worried about these little guys here. Those are the people that came to the party, and they're just kind of sitting in the back of the room, not talking to anybody. Like, why are they there? Why are we seeing so many little things from them? Is there something special about those cameras? Were they isolated incidents? If your company deals with retail, particularly down here, and you have retail in the Philippines, one of those places appears to be a mall in the Philippines, and the mall seems to be full of restaurants. So if you're a company like KFC and you want to protect your recipe, and you're not going to have vulnerable cameras in there that can, where somebody can jump in and steal that, because as we talked about earlier, yeah. Get your urgent. No, seriously, when KFC moves that little piece of paper, it's like Fort Knox. Because that is their bread and butter. There's so many people that claim that they have the Colonel's original recipe, but very few do. All right, actionable findings. So tying into this, we can see here all the yellow dots. these are ports. These are all coming from the packet captures. These are ports that were grouped together. Hey, I'm seeing 7547 as it's established communications. I'm seeing this 121 on ports. I'm seeing that, like, the way this column reads, UDP traffic, that's all UDP traffic that I saw in there. These are ports that were established connections. ICMP traffic, those are the frame numbers of some interesting ICMP packets that I should look at. And these aren't ICMP packets associated with a port not being found, router solicitation, things like that. These are protocol, what I would deem as protocol anomalies that we should take a look at, which all boils down to this. This is why you're here. So we had 51 binaries. Now you could give those 51 binaries to your team, run them in your sandbox to kind of develop an actionable plan. People do that all the time. But with the script that I'll give you, when I release all the data, is I wrote a wrapper for a T-Shark, and I just looped through the packets, and it came up with this. So all 4 segments here, we're dealing with these clusters of 6 malware hashes. So they all dealt with established connections on 2023, 666, 443, 757, and 2323. Some of those we're used to seeing. Others, is that a backdoor port that we're communicating on? The ICMP traffic, since it's not consistent across all of them, are those packets, what are they there for? Was it something specific to the network that was acquired? Is it something attributed to the malware? But either way, it's something that should be looked into, because you can deploy that in your IDS, and now you can see you can find out where else this is happening. UDP traffic, I can tell you from looking at these, that is all DNS. Now you have associated domains. You can add to your indicator list. You can start building that report. And lastly, the non-IPv4 traffic, those are IPv6 packets that we're coming across. Also, something else that we should take a look at, because why are we seeing that? We shouldn't be seeing that, especially coming from here. Those are the server configurations that we had identified. A bulk of them were unidentifiable. Next was NetWave. But it still really doesn't tell me what vendors should I be concerned about. The previous slide, it showed you that they were all identified as Mirai or Bashlight, which you can now tell if we can identify these. We know that this traffic, without a doubt, is tied to these addresses, and we can start moving forward. And so, So how do we dig deeper into this problem? And we figured that out because I gathered all the index pages and going through the metadata and the tags, I thought, maybe they put something in the title page because vendors like to brag, people like to brag, maybe it's in there. Lo and behold, those vendors right there that you see, those cameras are all majority Panasonic. So those were the cameras, those models were the ones that were compromised, that were able to point one-to-one. These model numbers were compromised. So if you have these model numbers on your network, or if you're selling them, you might want to look into that. Whoa, is this, let's see what else is going on here. Now, the other interesting thing that I'm still working on trying to figure out, there's a BOLO mark camera. And I couldn't find too much about the vendor, but there was one vendor that showed up where they have a very high-end infrared camera. Now, if you're using infrared, you're protecting something important. I mean, we're talking like Sneakers, the movie Sneakers. You got to wear the suit, walk slowly, get your body temp up to 98 degrees in the room, so that way, you can walk across the floor. I mean, just from seeing that, what are they protecting? And then also, if you have a camera that's that expensive and it's that owned, man, are your secrets still there? And lastly, one of the things that I was able to figure out, because this is the piece de resistance, the thing you all wanted to know, what were the motives behind this. The bad guys. Why did they do all this? And realistically, I figured out that they were all closet Trekkies and they were trying to take over the world because the data told me so. So there you have. You have. So now what this is one of those examples where data visualization is not really going to help you, but it makes it funny. But what this is telling me is what this chart actually depicts are the relationships of all the port configurations, the destination port configurations, and the United States is at the center of this. So all jokes aside, you know, if I wanted to really look into this, I would say, okay, obviously things are originating from the US, and they're targeting these ports. Now we know a lot of this traffic that is originating from the US isn't actually from the US because, you know, it's coming from other countries, but this is what we're seeing. And you can see back here, hey, we got that one port configuration that's just going in between those two, like what's that there? So obviously I would redo this and present it in a different way, but visualization can help explain your data better, especially when you add colors and you keep it simple. But when this one showed up, because there's actually, I probably made about 12 or so different graphs, and most of them were just not even worth it putting that in there. But this one, I thought this was funny. And as I said, I like to tell bad jokes, and I think I'm funny. So the recommendations: enrich your data as much as possible. Graphs and other visuals are your friend. They can work with you. They can also work against you. Don't be afraid to be wrong. Sometimes, you know, we learn from our mistakes. So that's what we want to try to do, learn from our mistakes. I love what I do, and I try not to be wrong as often as possible, but there was a situation where I was chasing a rabbit down a protocol anomaly hole, and I got confused in some of the data, and I made an incorrect prediction. But, you know, normally when you do those things, that can be damaging. It could, depending on the situation, it could be career ending or job ending. But in this situation, it actually helped uncover another flaw as we started to confirm it, which we saw that the server that the attacker was coding for, they didn't account for something specific in the interaction. And so it helped us identify, wow, they're only targeting this version of the software. Sometimes a cigar is just a cigar. What that means, sometimes there's no explanation. Sometimes the data is what it is. And then also, remember to chase the rabbit. Because every idea starts from some crazy notion. And that's what we build upon. And I want to thank Dtux for helping me out with, they gave me increased API access so I can gather a lot of the binaries and PCAPs that you saw. And it was very, very helpful. And I also want to thank all of you, most importantly, for attending this talk. And there's my contact info. And thank you. Thank you for coming.